All right, y'all. I am now going to do the rest of these examples. So I'm going to move through this relatively quickly because these are now meant to be the references. So if you're stuck and lost, I'm going to start with number 4. 9x plus 36. Is there anything I can pull out of this? Yes, I can take out a 9, which leaves an x plus 4 in its place. It leaves an x plus 4 in its place. And what do I have on the bottom here? I have a 9x. Now, 9 is a separate term from x plus 4. They can go together, but they're separate right now. This 9 and this 9x are also separate terms. They can be counted as one term, but they can also be counted as two terms, depending on what you need. So I see a 9 and I see a 9 that can cancel out. Mister, but can the x right here cancel out with this x here? No, it cannot, because x plus 4 is the term. X is its own separate term. Do these terms match? No. Remember, we can make this our one term. When we have parentheses, this means this belongs together. And when you see that plus sign or a minus sign there, that should tell you you should watch out for those. When it's straight up multiplication, it's easy. But when you have plus and minus signs, your little alarm bell should go off and realize this is not okay. You can't just come through and cross off x plus 4 and x. They're not the same things. But this 9 right here, and I can put this in parentheses to show you, this 9 right here is same terms. So I can cross that out, and then what am I left with? X plus 4 over x. You're going to ask me a bunch of questions of why you can't cross out x plus 4 over x. I'm going to show you in purple why. Let's say I had x equals 3. Are you ready? Let's say I had x equals 3. Now I'm going to plug in 3 plus 4. I'm making this up, y'all. Here's the answer, x plus 4. I'm plugging in my 3 right here, divided by 3. Now this is 7 over 3. Does 7 over 3 cancel out? No, it does not. So that's why you can't just cancel out these x's, because when you actually plug in a number and you add 4 to that number, it's no longer the same number. So you can't cancel it out. So that's the pseudo explanation for this, but keep that in mind. Now I'm going to the next one. 2 minus x doesn't simplify. That's awesome. For those who don't like the way this is written, I don't blame you. I'm going to rewrite this. I'm going to put the negative x first, because I like my x's first. So my negative x goes first, and this is a positive 2 here. So I'm going to rearrange it like that. So I'm going to have negative x plus 2. And again, I just rearranged it over 3x minus 6. But I'm going to do some work. I see this 3x minus 6. I'm going to pull out a 3. I'm going to pull out a 3, and I now have x plus 2. Not plus 2, minus 2. X minus 2. Okay, now this is where it gets tricky. This is a difficult one. You see this plus, and you see this minus, and it's not doing what we want it to do. Like, we want this to actually, work. You see this negative here, right here. This is one of those tricky things. This is hard to do, and this is hard to make sense of. So I'm going to go ahead, and I'm going to try my best to explain this. But what I want to do is I want to pull a negative number out from the denominator, because I'm trying to get this minus and this plus to match up. That means I need their signs to change. So from this part of it, I'm going to take out a negative 1. And let me show you what that looks like. So the top is still negative x plus 2, right? The bottom right here is still going to have the 3. I'm going to write that 3 right here. And then I'm going to pull out a negative 1 as well. I'm going to pull out a negative 1 as well. And I know this is weird. Just get over it. Like, life is hard and life is weird. So I can already hear y'all complaining, and I'm like, ugh, yeah, just do it. I pull out this negative 1, and now what's going to happen is I can switch this sign. This goes to negative x, and then this sign switches to positive 2. And then, my goodness, check it out. What do you notice? What do you see? Those things now work. So this and now this cancel out. Again, if nothing is left over on top, it's a 1. 3 times negative 1 is negative 3, and that's your answer. You have your answer. Pretty cool. I know that's a lot. Go back and watch it again. If you understand GCF, this stuff is going to be fun. If you don't understand GCF, this stuff is going to be miserable, and you're going to learn GCF, because I'm pretty much over it. All right. With that said, I'm going to go ahead and solve number 6. This is an easy one. Difference of squares, y'all. Perfect square, minus sign. Perfect square. X plus 7 times x minus 7 over x plus 7. Check it out. Boom, boom. That simplifies. And what am I left with? Well, I'm just left with x minus 7. That's it. Not even a new denominator. Mister, but the denominator, shouldn't there be a 1 down here? Yes, there's a 1 down here. When you cross this out, there's a 1. But do we put the 1 on the denominator? No. So that's that. I'm going to go ahead to the next example. This one's fun. I'm going to work these faster now. Again, this is all GCF. I'm going to pull out a 2 on the top one. So I have x minus 3. I'm going to pull out an 8 on the bottom one. And I'm going to end up with, I want this? 2x minus 6. Yeah, let's see what happens. Then I have an x squared minus 24. Not 24, sorry, x squared minus 3. This is a good example. So this right here, this is a good example. This right here, your brain is going to be like, oh, check it out, x minus 3 and x squared minus 3. I can just cross this out and it's going to be fine. But again, and I'm going to show you over here, let's say I put inside there the number 3, not 3, yeah. Let's see, 0, 3, yeah, I'm going to put the number 3 in there. Let's say I had x equals 0. You don't have to write this down. And I plugged in my x equals 0, and I did 0 minus 3 on one side, on the top, and then I did, not x equals 0, I don't want x equals 0. I want x equals 3. So let's say I plugged in 3 on the top. So I get 3 minus 3. I'm doing this one right here, which equals 0. And then let's say I also plugged in for this one, x squared. I plugged in 3 squared minus 3, which would give me 9 minus 3, which is 6. I would end up with 0 over 6. Does this term match this term? No, they do not. This term does not match this term. That's why you cannot reduce this x minus 3 and this x squared minus 3. They're just stuck. But you can see that number up there, 2 divided by 8. I end up with a 1 on the numerator because it divides out the 2. And then I end up with the 4 on the denominator. And that's it. That's your simplified answer. Pretty neat. Going to the next one. Number 8. I'm going to go ahead and do this. I'm going to pull out my 2, and I get x minus 2. And then, y'all, we've been doing the ABCs. Welcome to it. I am done showing y'all factoring. If you're still struggling with factoring, I'm going to be pulling you from math time as well, too, because I have had enough of this. I'm going to factor this in my head real quick. I know that this has to add up to 1, and it has to multiply to negative 6. So those numbers that I'm looking for, let's see. Those numbers that I'm looking for... It has to be 2 and 3, positive 3, negative 2. Yep, those are the numbers I'm looking for. So I'm going to break this up into x minus 2 and x plus 3. And check it out. My x minus 2 cancels with my x minus 2, and we're left over with 2 over x plus 3. I love these problems. This is like math fun. It's just so satisfying. So, and this is as fun as math gets. So if you're like, okay, mister, we get it. It's fun. Just shut up and pretend it's fun because I love it. Now, I'm going to go over here, and I'm going to solve this one. Once again, I hate my 3 minus x thing. My brain doesn't work that way. So I'm going to rewrite this so I can understand it. Negative x plus 3 over x squared plus 2x minus 15. I'm going to factor this. Y'all need to do your ABCs. Hopefully you're getting faster at this. Some of y'all, I think, are picking up on the shortcuts on these problems, which is great. I'm going to go ahead and write my x's here, xx. When this is a 1 right here, I can just put my x's. 3 and 5. Let's see, 3 and 5. And it's got to be minus 3. Is it minus 3? And it's got to be plus 5. How do I know that? My a is 1, b is 2, c is negative 15. My ac is negative 15. So 3 times 5. Let's see, it's got to multiply here, add here. So 3 times 5 with this one being positive and this one being negative. So negative 3. Plus 5 gives me 2. Negative 3 times 5 gives me negative 15. This is the correct answer. But check it out right here. This thing isn't giving me what I want. So watch my next step. On the numerator, I'm going to pull out this negative x. I'm going to pull out a negative 1 from the top. So I'm going to pull this out from here. And what ends up happening is this x changes to positive, and then this 3 changes to negative. And now I have that right there, and I have x minus 3. X plus 5 right here. And then here we go. X minus 3 cancels with x minus 3. X minus 3. And now you're left with negative 1 on top and x plus 5 on the bottom. So I believe in y'all. Y'all can do this. These, like I said, these are fun. I'm going to go ahead and solve the next one. 2x plus 6. I'm going to go ahead and take the 2 right here, and I'm going to have an x plus 3. That's just GCF. Look at me breaking it down. And then this sucker. All right, I'll label it. A is 3, B is 7, C is negative 18, and let's see, AC is negative 18. Negative 18 is AC. My bad. C is negative 6. Okay, so I have to multiply to negative 18 and add up to 7. So I think it's this. I think our numbers are positive 9. Yeah. And negative 2. Yeah, those are our numbers. So I now have to break this thing up. This is going to be ugly. And these are, of course, the Mondo problems, right, y'all? These are the Mondo problems that are kind of hard to do, but they're fun. 9x minus 6. So I'm going to go ahead and group this up. I'm going to take out my x on this one, and I'm going to be left with 3x minus 2. And I'm going to go ahead and take out my 3 on this one, and I'm going to be left with 3x minus 2. Work. Check it out. This one matches. So I have x plus 3 and then 3x minus 2 on my numerators. I mean, my denominator, I'm sorry, the bottom. So see this thing right here? I just did this whole crap, all this page of work just to get down to here. But it's worth it because now I can put it on the denominator. And now I can cross stuff out. So x plus 3 and x plus 3 cross out. And now I have this. And if I'm moving too fast, just reduce the speed of the video. That's that on that problem. Do we have any more to do on this page? I don't think so. I think that's all of them. Good for us, work. This is for any kids who are absent, anyone who needs to see each of these worked. I know my work is ugly looking, but it's correct. So with that said, that's it. Insert the outro here. Have a good day, y'all.